Hey YouTube, we got to show you what we got going on because it's the coolest thing in the world. My name's Dr. Kirk.
I'm Dr. Allison Justice.
And we are running smoking experiments for a series of experiments called the Science of Smokeability, where we are trying to figure out what cultivation or growing metrics, as well as drying and curing metrics, lead to high quality smokable cannabis flower. So this machine is called the combustion machine, and essentially we are smoking pre-rolls with the flower grown by Dr. Justice here. And we're taking a bunch of parameters as it's smoking through, and we're going to show you in just a second here. And then we can better understand water activity in cannabis products. Would you mind running through water activity and what that means?
Absolutely. So we have water activity and moisture content. And it's important that we specify which one we're testing for. We will indicate both, but we're actually making our tests from water activity because for cannabis, this is the most important thing. If you're thinking health and safety, we dry our cannabis down to a certain moisture activity because we want to ensure that microbials do not continue to proliferate and grow if they are there in the first place. So once we get down to a certain water activity, we're safe. But there's differences in preference, right?
Yes, there's preference to that level of water activity, but really what you need to know is really wet weed grows microbials, so we need to have it really dry, but is too dry, is that going to affect our smoking experience, that maybe it's like really harsh, maybe it's even producing some potential compounds that we don't want to produce. So this whole experiment is evaluating 3 different water activities, 0.45, 0.65, and 0.85. 0.85 is really high. You're not going to see legal cannabis products at 0.85 water activity because, as Dr. Justice was saying, that's when your fungi and bacteria start to grow because they need water to thrive and survive. So we don't want to give them water.
But we're scientists, so we want to test those very large ranges of variables. Of course, we would never smoke at 0.85, but let's see what happens.
Although we actually did. We did one time because we were curious, but it was like, it's very hard to smoke. It's too wet. You have to relight it like every 5 seconds. But anyway, we're going to walk you through this machine now and then drop any questions that you have on this machine or drop what smoke experiments that you want to see in the future in the comments and we'll get back to you. All right, so we start the experiment here. Then we can look at our puff topography. Then over here is where the joint's actually smoking. You can tell when it takes a puff, it'll turn red, so that was a puff. This is our ash collector. And then this blue wire that you're seeing is actually attached right to where your mouth would be. And that's measuring the temperature of the air or the smoke entering your lungs or your body. This is also our ashtray guide. This whole series of experiments is called the Science of Smokeability. This is phase 1, that's evaluating water content. Our future experiments are going to study the impact of flushing and what that means for the chemistry of what's entering in your body and a bunch of other interesting experiments. So after this machine is smoking the joint and it's sucking it in, it's going to enter here, where the smoke is going to be filtered through a solvent, and the solvent is collecting all the chemical compounds that we're going to later analyze using HPLC and mass spec to understand cannabinoids like THC and CBD, terpene concentrations, as well as toxicants or things that could potentially be harmful in the smoke.
Yeah, come check out the infrared camera.
Check this out. So this is on the other end where we're actually measuring the temperature of the ember of the joint. And that was a really cool part to see because you just saw the ash fall off. And did you see how much hotter that got when the ash fell off? Because the ash is protecting it from the camera from getting an accurate reading. So that just jumped quite significantly. This is just the beginning of a series of really cool experiments. And it wouldn't be possible without the sponsors of SOS that I'll put on the screen.
Sponsors.
Yeah, thank you sponsors, and thanks for the support. We can't wait to share the results with everyone.